Hello everyone. In this video I am going to explain one of the very important concepts that is structure of atom, which is there for CBSE 9th as well as state 9, whereas the same topic is covered in ICSE 9th. Even some basics part is there in ICSE 7th, that is as atomic structures. So what we are going to learn in this chapter is we are going to learn the different models of atom, like J.J. Thomson's model of atom, Rutherford model of atom, Bohr model of atom. Apart from that, we will learn the different concepts of an atom. That atom consists of nucleus as well as orbit, where are electrons, protons and neutrons situated or located. Okay, what is their atomic number, mass number of the atom, isotopes, isobars. We will also learn the electronic configuration of the atoms, and we will also learn the valencies, how to find the valencies of the different atoms. So let us start. Okay, so let's start the structure of atom. First, concepts. Okay, see, when we talk about any atom, okay, try to understand when we talk about any atom, generally first you see the modern structure of atom. Okay, generally atom is we are representing like this as a sphere. Okay, in this part only you see we have at the center we have nucleus, at the center we have nucleus. Okay, okay, so you can see here this is a nucleus. Okay, this is nucleus. Inside the nucleus we have two fundamental particles, P and N, where P stands for proton, P stands for proton, and N stands for neutron. Is it clear? See what happens, electrons are revolving in circular path around the nucleus, that is called as orbit. Okay, here around the nucleus we have a circular path. This path is called as what? Orbit, or also called as cell. Inside the cell what happens, electrons revolve. Okay, E stands for what? Electrons. So this is first things you should know, that is the modern concepts of atom. Okay, atom is having nucleus at the center, whereas electrons are revolving around the nucleus in circular path. Okay, here we are representing proton as P, neutron as N, electron as E. When we talk about the charge, what is the nature of these particles? Okay, proton is generally positive charge. Okay, neutron neutral, that is no charge, whereas electron is negative charge. We'll discuss, okay, one by one. Okay, so now let's see what is given. So before starting, you should know about the first scientist was John Dalton, who gave the atomic theory, actually we can say. Okay, what he told in his atomic theory, he told all the matters. Okay, we are talking about Dalton's atomic theory. Let's see. Dalton's atomic theory. Okay, just listen the points clearly. Okay, he told all the matters are made up of very tiny particles. Okay, these tiny particles are nothing but atoms, or it may be ions, or it may be molecules. Is it clear? Then second point, he told all the atoms of same elements are identical in properties. Okay, like they have the same shape, same size, same atomic number, same mass number. He also told that atoms of different elements are different in properties, like color, shape, density, atomic number, mass number of different atoms will be different. Like when we talk about the atoms of gold, it will be different from atoms of silver or copper. Okay, he also told that atoms of the element take part in elementary reaction. Okay, these are the postulates of Dalton atomic theory. So after the discovery of electrons and protons and neutrons, as Dalton had told that atoms is indivisible also. Okay, we cannot divide the atoms and it is the smallest particle, but that is not the truth. Okay, currently we know that atom contains nucleus, and inside the nucleus we have protons and neutrons. Okay, and electrons are revolving around the nucleus. So his postulates, his theory failed after the discovery of electrons, protons and neutrons. Similarly, his postulates failed after the discovery of isotopes and isobars, that we will see in the see later. Okay, is it clear? So here one table is there, can go through the table here. This table very important. Matters is made up of tiny particles called atoms. Matters is made up of tiny particles called atoms. Okay, atoms are made up of three fundamental particles, just as I discussed: protons, neutrons and electrons. Okay, charge. When we talk about the charge of proton, it is proton charge is what? Plus 1.6 into 10 to the power minus 19 coulomb. Okay, this is the charge of proton. Okay, whereas neutron has zero charge. Electron charge is what? Charge of electron is minus 1.6 into 10 to the power minus 19 C. C stands for coulomb. Coulomb is the SI unit of charge. SI unit of charge is what? Coulomb. Okay, proton mass is generally 1 AMU, neutron 1 AMU generally, electron 5.4 into 10 power minus 4 AMU. Okay, try to understand the mass of the proton. Mass of the proton is 1.672 into 10 to the power minus 27 kg. In kg it is like this. Okay, where is the location of proton? It is present inside the nucleus, just now I told. Whereas the mass of neutron is 1.67493 into 10 power minus 27 kg. Okay, and it is also situated in the atom, inside the nucleus. Electron, okay, mass is 9.1 into 10 power minus 31 kg. Okay, electron mass is how much? 9.1 into 10 to the power minus 31 kg. Whereas proton also you can remember, okay, 1.6 into 10 to the power minus 27 kg. Generally, mass of proton is generally equal to the mass of neutron, approximately equal. It is not exactly equal. You can see slight difference is there. It is 1.672, here 1.674. Is it clear? So where is the electron situated? Outside the nucleus. Is it clear? So just now I explained. Okay, atom, this is the nucleus. Inside the nucleus, protons and neutrons are there, and electrons are revolving around the nucleus in circular path. That path is called as orbit, or also called as shell. Okay. So protons and neutrons are almost of same mass, as I told you. Okay, generally the mass of proton is approximately 2000 times as that of the mass of electron. Okay, MC question may be asked, generally what happens? Mass of proton. Okay, when we talk about mass of proton is approximately 2000 times as that of the electron. Generally mass of neutron is more actually than the mass of proton, then mass of electron. So mass of neutron is maximum, then mass of proton. Okay, remember one times, generally mass of proton is approximately equal to 2000 times, okay, of mass of electrons. These concepts important. It is actually 1837 times. Okay, next concepts, let's see. J.J. Thomson's model of atom. We discuss about the J.J. Thomson's model of atom. What J.J. Thomson told? He told an atom is a sphere of positive charge, okay, in which negatively charged particles called electrons are embedded into it. So let's try to understand, then we will go through these concepts. Okay, J.J. Thomson's model of atom. J.J. Thomson's model of atom. So I'm just, this is a sphere actually. He told the atom is a sphere of positive charge. So what is the nature of this sphere? It is positive. Okay, this is positive sphere. Positive sphere. Okay, in which negatively charged particles called electrons are embedded. So you can say these are what are embedded electrons. Embedded electrons. Is it clear? He also told that the magnitude of positive charge is equal to the magnitude of negative charge. So atom as a whole is a neutral. Is it clear? Okay, na? So this question may be asked for 2 marks to 3 marks. Okay, so you have to, I'll show you one diagram. Okay, is there? Okay, in this the diagram is not there. I'll show you. J.J. Thomson's. Okay, so you can see any one diagram, you can see, no issue, you can see. Okay, this one also. Atom is a sphere of positive charge. Okay, sphere of positive charge in which electrons are embedded. You can see here. Again, atom is a sphere of positive charge. Okay, this is a embedded electrons. Right. Okay, it is a sphere of positive charge, a sphere of positive charge in which electrons are embedded into it. Is it clear? So let's go through the postulates. Okay, here Dalton atomic postulates is also there. You can go through. Okay, what is Dalton atomic postulates? Detailed model of atom was first of all proposed by J.J. Thomson. As I told, Thomson proposed that an atom consists of uniform sphere of positive charge in which the electrons are distributed more or less uniformly. Thomson proposed that the model of an atom to be similar to that of the Christmas pudding. This model of atom is popularly called as plum pudding model. Okay, you know that watermelon, right? So reddish part you can assume as a positive part. Okay, positive sphere in which black color seeds are there, that you can assume as a electrons. Is it clear? So that is popularly called as watermelon model. So electrons in the sphere of positive charge were like currants, dry fruits in the spherical Christmas pudding. We can also think of the watermelon. The positive charge in the atom is spread all over the the red edible part of the watermelons, while the electrons are sudden in the positively charged sphere like seed in the watermelon. Is it clear? So just in short, we can say that according to J.J. Thomson's model, an atom is a sphere of positive charge in which negatively charged particles called electrons are embedded into it. Okay, that's all. Next, we talk about Rutherford gold foil experiment. Okay, what Rutherford did, he took alpha rays. Alpha rays are nothing but positive rays. These are the alpha rays. Okay, alpha rays. Alpha rays are nothing but positive rays. He passed the alpha rays through the atom of gold. Okay, what he noticed that most of the alpha rays pass through the foil without any deflection. I'll explain you. One question may be asked, why he chose the gold only for his experiment. Okay, was he very rich or some other reason was there? Okay, anyone, you can comment. See, actually gold is most malleable element. He wanted a very fine thin sheets of atom. That's why he chose gold. Yes or no? So let's start. Okay, Rutherford experiment. Rutherford experiment. Rutherford gold foil experiment. Gold foil experiment. This question is very important. Maybe asked for 3 marks. Okay. Generally, this questions related to this is asked in the annual exams. So what he did, he took the atom of gold, okay, and he passed alpha rays through this. He passed the alpha rays through this. He took a alpha rays. He passed the alpha rays. Okay, these are nothing but a alpha rays. Alpha rays is a positive. Alpha is similar to what alpha rays resembles, and it has the atomic number 2, mass number 4, helium particles. So what he did, when he passed millions of alpha rays through the atom of gold, this is a sphere is nothing but a atom of gold. I am showing with one atom of gold. So what he noticed, most of the alpha rays passed through the foil without any deflection. It went straight through the atom. Okay, few rays deflected by small angles. Okay, it was going like this, but what happened? It deflected like this. Okay, similarly few rays you can show which were deflected. Okay, few rays deflected by small angles, whereas one in approximately 20,000 bounced back. Okay, it went like this or suffered major deflection, we can say. Okay, it came like this. Okay, now, so this is a roughly, okay, rough diagram of Rutherford gold foil experiment. What he did, he passed alpha rays through the atom of gold. He noticed that most of the alpha rays passed through the foil without any deflection. Few deflected by small angles. Okay, you can see few deflected by small angles. This light ray, it was supposed to go like this, but it deflected by a small angle. Here also few, very few, okay, suffered major deflection, or one in approximately 20,000 bounced back. Okay, so what he concluded after his experiment that most part of the atom is empty, because most of the positive rays is passing undeviated without any deflection. See, some rays which are getting deflected, the region is what they are passing close to the nucleus, which is positive charge. Okay, and the rays which are directly hitting the nucleus, you can see this rays, okay, which is directly hitting the nucleus or very close to the nucleus, is suffering major deflection, or similarly you can say it is bouncing back. Okay, few, okay, which is directly hitting the nucleus is bouncing back like that. It is just bouncing back. Okay, so let's see. Okay, in 1911, scientist Ernest Rutherford gave a new picture of the structure of atom through his alpha particles scattering experiment and proposed the structure of atom. Okay, see here, when fast moving alpha particles strike very thin gold foil in vacuum, it is found that, okay, these are the observation, okay, that you can note it down. Most of the fast moving alpha particles pass straight through the gold foil without any deflection from their original path. Is it clear? Second one, some of the alpha particles were deflected by the foil by small angles, and few were deflected through large angles. Okay, and very few alpha particles completely rebound on hitting the gold foil and turn back on their path. Okay, you can see here also this diagram. Okay, most of the rays is passing, few are deflecting by small angles, and few are deflecting by major angles. Okay, and 1 in 20,000 bounces back. Is it clear? This question may be asked for 2 to 3 marks. So what he concluded, actually, he gave in his model of atom. He concluded that most part of the atom is empty. Okay, and he also told that there is a very small positive part present inside the atom. Okay, that is nothing but a nucleus, he named. Okay, and he also told that the volume or size of nucleus is very small compared to the size of atom. Okay, size of atom is approximately 10 to the power minus 10 meter, whereas size of nucleus is 10 to the power minus 15 meter. Is it clear? Okay, so let's see the postulates. Rutherford concluded from the alpha particle experiments that most of the space inside the atom is empty because most of the alpha particles pass through the gold foil without getting deflected. Yes or no? Most of the alpha particles are passing on, because if it is positive charge and it is neither after crossing any foil, it is neither getting attracted nor repelled. It means the space is what? Empty. Yes or no? Like that. Okay. Next, very few particles were deflected from their path, indicating that a positive charge of the atom occupies very little space, and a very small fraction of alpha particles were deflected by 180 degree, indicating that all the positive charge and mass of the gold atom were concentrated in the very small volume within the atom. Okay, so finally we can conclude there is a positively charged center in an atom called nucleus. Nearly all the mass of the atom resides in the nucleus. Very, very important. The electrons revolve around the nucleus in well-defined orbits. The size of nucleus is very small compared to the size of atom. You can note down also that size of atom. Okay, you can note on this, very, very important. Generally, size of atom is 10 to the power minus 10 meter, whereas size of nucleus is 10 to the power minus 15 meter. Is it clear? Okay, let's go to the next concepts. There were some drawbacks. This question also may be asked for 2 marks. Mention the drawbacks of Rutherford gold foil experiment. So what the drawbacks were there? Let's see. According to the Maxwell, if an electrically charged particle revolve around the circular path, then it always radiate out energy. Thus, if the electron moves around the nucleus, it must continuously radiate out energy and hence gradually move towards the nucleus in a spiral path. It will collide with the nucleus. Actually, what happens? He could not explain the stability of atom. Let's see. Okay, what he told. Okay, try to understand. I'll explain you. Okay, he told in his model of atom that atom contains nucleus. Okay, na, and electrons are revolving around the nucleus in circular path. Okay, electrons are revolving. Actually, if any particle is revolving around anything, okay, let's take electrons is revolving around the nucleus. So it should lose energy or it should radiate energy, yes or no? And finally, it should collapse with the nucleus, yes or no? So it means he could not explain the stability of atom, but that is not happening. Electrons are continuously revolving around the nucleus in a circular path. But he told that electrons are revolving, okay, around the nucleus. So whenever it is revolving, so it must radiate energy, it must lose energy, yes or no? And it should finally collapse with the nucleus, but that is not happening. Okay, what is actually happening is atom contains nucleus and electrons are continuously revolving around the nucleus in circular path. Okay, so we can say he could not explain the stability of atom. Okay, next here. Just now I discussed, you can note on these points. Now what happens after Rutherford, Bohr came, okay, and he gave his own atomic model, which is very, very important. Currently this is also called as modern atomic model also. Okay, what he told, try to understand. Let's see the postulates first. It is a quantum mechanical model. Okay, this model was based on the quantum theory of radiation and Planck theory, which you will study in PUC or class 11th, and the classical law of physics. For your kind information, remember these points only. Okay, electrons revolve around the nucleus in very well defined orbits or shells, each cells having the definite amount of energy associated with the electrons in it. Therefore, these cells are also called as energy levels. He told what? That atom contains nucleus and electrons are revolving, okay, around the nucleus, but having definite energy levels, having definite energy levels. He also told that the energy associated with the electrons in an orbit increases as the radius of the orbit increases. Means he told that n is equal to 1 as a k shell, first orbit, n is equal to 2 means second cell, okay, L cell. Okay, let's see here first what he told in diagram. Ruther है ना, बोर मॉडल है ना, बोर्स एटॉमिक मॉडल. Okay, he told atom contains nucleus in the center and electrons are revolving around the nucleus in circular path. Okay, the paths are called as orbit or shell. This is the first n is equal to 1, he named as what, n is equal to 1 as k shell. This is second orbit right now, so n is equal to 2, he named as L cell. This is the third orbit, n is equal to 3, he named as L cell. Is it clear? He also told that these orbits are having fixed energy levels. First cell will have less energy, as the number of cells increases, energy level also increases. Okay. He also told that when electrons are revolving around the nucleus, while revolving around the nucleus, it will not radiate energy. Okay, because these energy levels are fixed, which means it is not losing the energy. Okay, now let's go to the postulates. The energy associated with the electrons in an orbit increases as the radius of the orbit increases. Okay, these cells are also known as K, L, M, N, as I told you. An electron in a cell can move to a higher or lower energy levels or shell by absorbing or releasing a fixed amount of energy. Electrons can jump from here to here, or here to here, or here to here. Whenever you give the light okay, of certain energy, it will absorb the energy, it will go from one cell to other cell. Similarly, whenever electrons come from the higher level to lower level, it will also radiate some energy, it will lose some energy. That he told. The amount of energy absorbed or emitted is given by different energies associated with the two orbits. Okay, try to understand this. Okay, these are the energy level size I told you. So we can represent this energy level size like, let's see here. These are the energy levels I am just showing. Okay, so here n is equal to 1 is there, n is equal to 2, n is equal to 3, n is equal to 4. What I am telling, suppose electron is there in the fourth cell. Okay, now so whenever it is coming to the first cell, so it will emit some radiation, okay. Similarly, whenever it is coming from third to second, so there this is energy of, this is what, E4, let's take, this is what, E3, energy of second cell is E2, E1. So whenever it is moving from higher energy to lower energy, it is radiating energy. Okay, it will radiate energy. Okay, so or in the form of photon, so light energy will be coming. Similarly, whenever electron is there here present in the second cell, this is the electron, let's say, whenever light of certain frequency falls on this, so it may absorb that energy and it may move to the higher cell. So that is happening inside the atom. Okay, now let's see the so you can, this question may be also asked for 2 to 3 marks. Now neutron distribution of electrons. Okay, see what is valency, try to understand. Valency is nothing but before learning valency you should know the electronic configuration. Okay, in Bohr only we'll see, we'll cover, then this topic becomes easy. Bohr had told one more point that the maximum number of electrons present in a shell is a 2n square. The maximum number of electrons in an orbit is given by how much? 2n square. Let's talk for example, whenever n is equal to 1, okay, n is equal to 1, so what is the electron, maximum electron? 2 into 1 square, that is 2 electron. N is equal to 1 means which cell? K shell. Similarly for L cell, n is equal to what? 2 is there, yes or no? Here you can see n is equal to 1 means K shell, n is equal to 2 means L cell, n is equal to 3 means L cell. Okay, here n is equal to 3. Okay, now so he had told that for second cell the maximum number of electron is what? 2 into 2 square, that is 2 into 4, how much? 8 electrons can be there in the second cell. Similarly, for the third cell, n is equal to 3, the 2 into 3 square, that is 2 into 9, 18 electrons can be there. MCQ questions may be asked based on this. The maximum number of electron which can be accommodated in, let's take okay, n is equal to 4 is, okay, so what is that formula? 2n square is the formula, right? Now n is what? 4, so 2 into 4 square, how much? 2 into 16, 32 electrons can be there, maximum number of electrons. Is it clear? Please make a note of this. Okay, now let's talk about the electronic configuration. Try to understand very important concepts. Electronic configuration. Okay, electronic configuration is nothing but the arrangement of electrons in the atom. The arrangement of electrons in the atom is called as electronic configuration. So being a good student, you should know that atom contains what? A nucleus. In the center, inside the nucleus we have protons and neutrons, yes or no? So let's discuss first atomic number. What is atomic number? What do you mean by atomic number? Atomic number is generally represented as Z here. Okay, so just now I explained that inside the atom we have nucleus. Okay, inside the atom we have nucleus. Okay, now, yes or no? Nucleus is there, and inside the nucleus what is there? Protons and neutrons are there. Protons and neutrons are there, and electrons are revolving around the nucleus in circular path. That path is called as what? Orbit. As the proton is positive charge, neutron is neutral, so charge of nucleus is what? Positive. Okay, E stands for electron. What is atomic number? Generally atomic number is nothing but a number of protons present inside the nucleus of an atom. Okay, for example, carbon atomic number is 6. Okay, nitrogen 7. It means carbon has 6 proton, nitrogen has 7 protons. Is it clear? Generally for the neutral atom, the number of protons and number of electrons are same. So we can say Z is equal to P is equal to E. Is it clear? Okay. For example, sodium. Okay, atomic number is 11. So how many number of protons? 11 protons. How many electrons? 11 electrons. Okay, fine. Let's talk about the mass number. Mass number is generally represented as A, capital A. What is mass number? It is nothing but a sum of protons and neutrons. Sum of protons and neutrons present inside the nucleus of an atom. Okay. For example, mass number of carbon is 12. Mass number of carbon is 12. Similarly, mass number of oxygen is 16. Is it clear? See, for any atom, okay, for any atom X, if is the atom, we are representing atomic number here generally on the bottom left and mass number here. What is Z? Z is the atomic number, and A is nothing but a mass number. A is nothing but a mass number, and X is the atom. X is the atom. For example, you see carbon 6 and 12. Some books it is represented also like this 6, 12. Okay. Nitrogen 7 and 14. What does this mean? Okay, try to understand what does this mean. Okay, it means what is atomic number? Let's see. What is a Z? Atomic number, mass number, proton, electron. Okay, Z atomic number is what? 6 here. Okay, only one I am taking. Let's see. This one you can erase. Okay, atomic number is 6 means Z is 6. Here, what is the mass number? 12. Number of proton is equal to what? Atomic number, that is also 6. Generally it is a neutral atom, so electron is also 6. Neutron, sorry, nitrogen, atomic number is what? 7. So Z is what? 7. Mass number is 14. A is 14. Okay, electron, how many? Due to the electron and proton is equal to the what? Z, that is equal to 7 and 7. Is it clear? If you want to know the number of neutron, okay, so number of neutron, here only you will see, as I have taught you that atomic number is Z, that is equal to number of proton. Sorry. Here you see, what is atomic number? Okay, atomic number is equal to number of protons. What is mass number? Protons plus neutron, yes or no? So you do A minus Z. A minus Z is nothing but a P plus N minus P. Subtract plus P minus P get cancelled. So number of neutron you can find is nothing but a number of neutron is nothing but a mass number minus atomic number. This formula also you have to remember, very very important. Okay, very very important, this formula. So here only we can say number of neutron. Okay, number of neutron, you see, number of neutron. Okay, for carbon, mass number is 12, atomic number is 6. So 12 minus 6, how much is the number of neutron? 6. For nitrogen, 14 minus 7, what is that number of neutron? 7. Is it clear? Like that, they may give you questions in the annual exams. Please note it down. Okay. Try for this. Sodium, atomic number is 11, mass number is 23. So atomic number Z is what? 11. Okay, mass number, what is the mass number? 23. 23. Number of proton, that is equal to atomic number. As it is a neutral atom, so number of electron and protons are same. What about the number of neutron? 23 minus 11, that is 12. Please make a note of this. Okay, you can take the screenshot also. I will move to the some more electronic configuration. I am taking some elements, very commonly used elements. I am writing their atomic number. Okay. Let's take some is required actually. Table is required. Okay, elements. Okay, elements are sodium. First lecture, sodium. Okay, symbol, I am writing symbol here. Symbol of sodium is what? Na, because its Latin name is natrium. Okay, here I am writing atomic number. Atomic number is 11. Here I am writing mass number. Mass number is what? 23. Here I am writing electronic configuration. Electronic configuration. Electronic configuration is nothing but the arrangement of electrons. Okay, na? This is very very important concepts. Okay, electronic configuration. Okay, so here just see in the electronic configuration we are writing first K cell, L cell, M cell. See, as we discussed, K cell can have maximum how many electrons? 2. L cell can have maximum 8 electrons. Okay, now total electron is what? 11. So 2 plus 8, 10 is there. So 11 minus 10, valence electron is what? 1. Okay, similarly come to the magnesium. Magnesium, symbol is what? Mg. Okay, atomic number 12. Okay, mass number is what? 24. Electronic configuration 2, 8, 2. First cell we can give maximum 2 electrons. Is it clear? Second cell 8 electrons if it is available. Third cell 18 electron, but 18 is not there, we can give less than 8. Is it clear? Next we are talking about aluminium. Al. Okay, atomic number is 13, mass number is 27. Okay, first cell 2, then 8 and 3. Is it clear? Now I am taking oxygen. Taking oxygen. Symbol is O, atomic number 8. Okay, mass number 16. Electronic configuration 2, 6. Okay, let's talk about nitrogen. N. Okay, atomic number 7, mass number 15, 2, 5. Okay, 7 electron is just first cell, 2 electron, next 5. Remember one thing, if the valence electron of the atom is generally 1, 2 or 3, it belongs to metals. It belongs to metals. and their valencies are also same. The last cell electron is called as what? Valence electron. So their valency is what? Valence electron. What is the valency? Is equal to valence electron. If the valence electron is 5, 6, let's take one more example, chlorine or 7, chlorine. Symbol is Cl. Okay, atomic number is 17. Okay, mass number is 35. So 2, first cell we can give 2, then 8, and the third cell 7. So you can see when the last cell is a third, valence electron is 5, 6, 7. Generally they belong to non-metals. They belong to non-metals, and their valencies are 8 minus valence electron. Valency is nothing but 8 minus valence electron. So for oxygen 8 minus 6, what is the valency? 2. For nitrogen 8 minus 5, what is the valency? 3. For chlorine, what is the valency? 8 minus 7, that is 1. Let's talk about argon. Argon symbol is Ar. Okay, atomic number 18, mass number 36, electronic configuration 2,8,8. If the valence electron is 8, then it belongs to noble gas. Okay, it belongs to noble gas or inert gas, noble gas, and the valency is 0. Please make a note of this, very very important. What is valency? The combining capacity of an atom is called as valency. Please make a note of this. Is it clear? Next. So generally, valency, it is the number of electrons that an atom should give or take to attain the stable electronic configuration. A stable electronic configuration is nothing but a octet rule. Okay, what is octet rule? Octet rule states that if the valence electron of the atom is 8, then it is a stable. Okay, is it clear? So generally, if the valence electron of the atom is 1, 2 and 3, so it will lose the electron to become a stable. For example, sodium. Okay, electronic configuration 2,8,1. To become a stable, it is losing 1 electron. Okay, so it becomes what? Na plus. Is it clear? Because 2,8. See, as the atomic number is 11, so it has electron 11 and proton also 11. Here, proton is what? 11 only, because proton number is fixed. But electron how much? Electron is 2 plus 8, 10 electrons. As it is having one extra proton, and proton is positive charge, that's why we are writing plus. Similarly, we talk about the chlorine. Let's see, chlorine. Chlorine atomic number is what? 17. Means it has 17 electrons, 17 protons, 2,8,7. So to become a stable means what? It should have 8 electrons too in the valence shell. So it will gain 1 electron. Once it gain 1 electron, becomes Cl minus 2,8,8. Why? Because here it has here no charge. Why? Because it has 17 proton, 17 electrons. Whereas here proton is 17, but electron is how much? 18. 2 plus 8 plus 8, 18 electrons. As it is having one extra electron, to show the presence of extra electron, we are writing minus 1. Is it clear? Okay, so here chlorine is gaining 1 electron to become a stable. Here sodium is losing 1 electron. Okay, to become a stable. Is it clear? So let's see the number of electrons that an atom should give or take to attain the stable electronic configuration, that is the valency. The electrons present in the outermost shell or orbit of an atom are the valence electron. Here what is the valence electron? 1. Here what is the valence electron? 7. 3 ways to obtain the stable configuration: by losing of electrons, just now I explained, by gaining of electrons in case of chlorine. Generally remember one thing, if the valence electron is 1, 2, 3, it will lose the electron to become a stable. If the valence electron is 5, 6, 7, it will gain the electron to become a stable, because gaining becomes easy. But if the valence electron is 4 in case of carbon, then it will share the electrons. Okay, by sharing the electrons. Okay, for example, hydrogen is there, right? Let's see, hydrogen is there. Okay, hydrogen generally is having 1 electron. This is a representation of electron. Here also 1 electron is there. Yes or no? So generally what happens, hydrogen will take 1 electron from the other hydrogen atom and become a stable. Okay, this is called as covalent bonding. We will discuss in the other chapters. Okay, here you have to note down. Okay, very very important, some elements are there, their symbols are given. Okay, and what is the atomic number? Like hydrogen, symbol is H, atomic number 1, number of proton 1. It has no number of neutron because hydrogen is represented as 1 1. So atomic number is 1, mass number is also 1. So 1 minus 1, what is the number of neutron? 0. So number of electron 1, number of proton also 1. Okay, electronic information, first shell K. So what is the valency? 1. Let's talk about helium, very very important. Okay, this question may be asked for 2 to 3 marks. Okay, helium, symbol is He, atomic number 2, number of proton 2, number of neutrons. Okay, helium is actually 2 and 4, mass number is 4, atomic number is 2. So 4 minus 2, that is 2. Okay, number of electron 2, electronic configuration, first shell will have 2 electrons. So what is the valency? 0. If the valence electron is 2, then it is also stable, and the valency is what? 0. This is in case of helium. Lithium, Li, atomic number 3, number of protons 3, number of neutrons 4. Okay, because lithium is there, again 3 and 7, atomic number 3, so proton is what? 3, electron is also 3, number of neutron, how will get? 7 minus 3, that is equal to 4. Okay, so 4, electrons 3, electronic confusion 2 comma 1. Okay, yes, and similarly boron we can see 5, number of neutrons 6, electron 5, 2 comma 3. So these we can see, okay, 1 to 3, they are what? 1 to 3, they are actually metals. Yes or no? Just now we discussed the sodium, magnesium, aluminum. Okay, now so sodium, you can see sodium 11, okay, atomic number 11, and number of protons 11, number of neutrons 12. Why? Because sodium is what? Atomic number is 11, mass number is 23. Okay, you have to remember the mass number. 23 minus 11, that is 12. Okay, number of electron is 12, so electronic configuration, sodium, number of electron is 11, 2 comma 8 comma 1. So what is that? Valence electron 1, so valency is also 1. Okay, so you please note on the table and work out. Okay, let's talk about the isotopes and isobars, very very important. When we talk about isotopes, okay, isotopes are the atoms of same element having same atomic number but different mass number. Okay, for example, isotopes, try to understand. Hydrogen is having 3 isotopes, atomic number 1 1 1, mass number 1 2 and 3. Okay, isotopes are nothing but atoms of same element having same atomic number but different mass number. Okay, what is same? Same atomic number, that is Z, and different mass number, that is A. You can see atomic number is same, mass numbers are different. Other example you can remember, carbon isotopes, atomic number is 6 and 6, mass number is 12, 13 and 14. Okay, here atomic number 1 1, mass number 1 is called as protium, number of proton is 1, number of neutron is 0, symbol is H11. Deuterium, number of proton is 1, okay, number of neutron 2 minus 1 1, where symbol is 1 2, H we are writing or D you are writing, deuterium. Tritium, number of proton is 1, neutron 3 minus 1, that is 2, so we are writing like this. Okay, where we are using isotopes, and isotopes of uranium, that is 35 to 35, okay, is used in the nuclear power plants to generate electricity, very very important. Okay, and isotopes of cobalt is used in the treatment of cancer, and isotopes of iodine is used in the treatment of goiter. Okay, yes or no? So very very important, where we are using isotopes. Isotopes of iodine is used in the treatment of goiter. Goiter is a disease in which this thyroid gland comes out, protrudes out. Okay, na, comes out means protrudes out. Okay, it is enlargement of thyroid gland. Similarly, isotopes of cobalt is used in the treatment of cancer. Isotopes of uranium is used in the treatment of, not in the treatment, it is used to generate electricity. Okay, as a nuclear fuel also we can use. Okay, next we have isobars. Isobars, let's see isobars. Okay, when we talk about isobars, okay, isobars are the atoms of different element having same mass number but a different atomic number. What is there? Different atomic number, that is Z, different atomic number. Okay, different atomic number but same mass number. A means what? Mass number is same. Example, you can see argon, potassium, calcium. Atomic number is 18, 19 and 20. Mass number is 40, 40 and 40. Is it clear? So these are what? Isobars. Please make a definition. Note down the definition. Isobars are the atoms of different element having different atomic number but same mass number. Okay, I tried to cover each and every concepts. Please watch the video and share with your friends. Don't forget to subscribe the channel. Thank you.